Good morning, everyone. Hi, welcome to the sessions on data and data in talk. My name is Dr. Saurabh Pramanik, and I would be working through these different sessions on data. Each week, what we do is we go through these different topics on data and primarily align to some of the standard practices, such as the DAMA, aligned to the DAMA curriculum, the CDMP certification. It will also help you in the preparation of a CDMP certification. So we have been going through different sessions. We have covered almost so many different topics on data, such as, for example, our data management, data ethics, data governance, data architecture, modeling, data storage, data security, data integration, document content management, reference data management. And each of these are available as separate recordings, so you can go to it. In today's session, what we're going to do is we will be going through the topic of data warehousing and business intelligence. Now, this is again a very interesting topic and a topic which all of you might be getting aligned with over the years through different part of your journeys with data. Now, the concept of data warehousing is something not new, right? It started emerging somewhere in the early 1980s and all, where organizations, as the data journeys get started, the similar problems started coming in. As you know, that multiple sources of data were existing. There were a lot of data, different departments having these different data sets and having different technologies. So now there was a problem that was happening because while getting the entire insights and decision making process, it was very difficult, to get a complete single view of entire data sets, right? So data warehouses were initially being thought is the best way to identify and reduce this proliferation of these decision support systems, the DSS systems that you know. And it all emerged from the word warehouse, where in the early days where Walmarts, Amazons and all were trying to bring the entire concept of rather than going to multiple retail stores, you can start getting it to a single place, to go to a warehouse or go to a mega, multiple, media store, or you can say a single place, right? You have these retail stores, you have the hypermarkets, right? So that's the whole aspect it was where now I want to extend it for my data. So I can do that. I can remove away, I can reduce my data redundancies. I will also improve my consistency of information, or, that is primarily the whole objective was data warehousing coming. So as per DAMA, the definition of data warehousing is data warehousing and business intelligence is more with respect to the planning, implementation, and the processes that are being improved that will involve how we can start involving and improve providing the decision and support systems. And this also embarked on as a kind of, you can say, enabler, or it basically inspired a lot of the other future concepts such as your data lakes, your data meshes, right? So few of the goals that Dharma mentions with respect to the data warehouses is first is so that I can start building and maintaining the technical environments and the technical and business processes that would be required. How I need to deliver integrated data in respect to my support of my operational functions, the compliance requirements. So these are all the different types of use cases that you will start seeing, how I can start getting operational functions, compliance requirements and all. So these are some things you can say the kind of the enablers when it organization starts with the data warehousing and business intelligence journeys. At the same time, I want to give my effective business analysis and decision making to my knowledge workers. And this Dharma wheel, which you are able to see, is primarily has these different components. So within that different components, you can see that the data warehousing and business intelligence is also one of the key pillars. Now, what are the different goals and principles that you will be able to see as part? Now, each day, each week, what we were doing while we were going through these different concepts, we have also been seeing the different context diagram, right? So these definitions and goals are part of that context diagram that we see, which basically is trying to get all of these into, information in a single place where I can now start looking into these these different components of how I would want to start using my data sets, right? Now, these also inspires and this basically takes, drives some of my key decision making. So here you can see the context diagram, the other side of the context diagram, which is more on the what are my business drivers, right? So here you can see the different goals and principles which are there, but before coming to that, you can see what are my different business drivers that I have. So these primarily gets inspired from the different business requirements that I would be getting from the different businesses. What is my scalability, operational infrastructure requirements that I have? What's the data quality, security, and access requirements that I have? What is the IT strategy? What are the related IT standards and policies and standards that I have? What are the internal data feeds that I have? Also the master data and reference data aspects, and then the industry and external data I have. I will also try to perform certain kind of activities such as to understand what are the requirements, define and maintain the data warehouse and BI architectures. I will also develop data warehouses and data marts, as part of the data warehousing activities. I'll populate the data warehouse with data. Once the data model is all created, I will also start implementing the business intelligence portfolio or the use case and as part of it. And I will try to maintain data products. Now, data products as a concept has been getting a lot of prominence where now I want to start imagining data is just like a product for me. And I want to start going through the entire product life cycle, just like I have. Similarly, I have the data life cycle for each of different steps. That basically helps me to start considering that data is an asset for the organization. And then as part of this entire journey, what are some of the key components that you do? So first and foremost thing is the architecture. There are different types of modeling styles that are exist. So as we go forward, we'll see, but that's the architecture, how you're designing, how you're defining and designing your data products, the entire population and the data loading activities, the governance activities associated, then the metadata activities, the lineage, the dictionaries aspects, then the learning and the adoption plan, the training, learning, upscaling people, then the release management and the release plan. How do you release it? Whether you want to go with a, one shot or, a full loading as a kind of a plan, or would you like to divide and, conquer that way? Then on the production support process perspective, what are the production support activities that would be there? Then on the load timing, load tuning, what are the, how will you be able to load tune the activities, and on the BI activity monitoring aspects also. So that is one thing. Then for these, you will have different suppliers of this data, like the business executives, the governance body, the enterprise architecture teams, the data producers who produce the data. You have the informing consumers or the data producers also, you can say. Then you also have the subject matter experts, the SMEs. Then as part of these activities, there are different participants. You will be there. You require to have a project sponsor. The CXO teams, the management teams, steering committee teams are part of it. You have the architects, you have the analysts, which are part of it. Then you have the different specialists, the data warehousing, BI specialists who are part of it, the project management team, the change management teams, all are part of the entire journey. Then on the consumer side, who are your information consumers? Who will be the consumers of all these deliverables that you have? Then you have the customers, you have the managers, executives. So these are all the business drivers. On the technical driver side, you might have certain key techniques. You will use certain kind of tools, metrics for evaluation. So on the techniques side, you can see that what are the different types of prototyping that you will be do, how will designing the data model within the data warehouse, what are the requirements to drive self-service BI. Now, self-service is primarily where now I want to make the data available. The IT team is someone who would be ensuring that the data is made available, into the data warehouse. But after that, I will give access to the business teams to start managing and use this data for their business MIS purpose, the business intelligence purposes. A lot of time that is also something that has been assigned to IT. So because it becomes too much difficult, a single IT team, which might be only consisting of 2 to 3 people, managing the request within the entire organization. So it becomes too much difficult. So now what I do is I do self-service. By providing self-service, I try to upscale my all the business teams and say that this is how you can start using this data, and you can start creating your own reports and start uh, taking care of your use cases as well. And then you can start writing queries. You can audit the data as well. On the tools perspective, there could be repositories that you want to create, data integration solutions, analytical applications you will require, right? And for driving the metrics perspective, you start looking at self-service, how it is being done. Currently the usage metrics will look into, you'll start looking into the customer user satisfaction indexes, what are the different subject areas, coverages that you will have. Then the response and performance metrics aspects that you will start looking into. All these are the different aspects that you will. Now, even though these data warehouses began to be built in the since 1980s and 90s, initially it was being popularized. Data warehouses took some time to become the mainstream, right? Now, still there are a lot of organizations they don't have data warehouses and data warehousing. That's the first step you can say when it comes to the consolidation or centralizing the data repository because data warehouses will be catering to a lot of your structured real data, structured data as compared to a data lake where the data is kept in a raw format. The data warehouses is more where you will keep the data in its more transformed state. The data is more structured and kept, and on top of it, you can start writing the query. So, we take a step-by-step approach, right? So even if you take a data lake is nothing but a data warehouse that you have plus your unstructured data that use cases that you will be having. And majority of your data is still very so structured, right? When you do data analytics and all. So that's this the reason, data is formed a very core component of any of your data journeys. And now you have concepts like data lakes, you have data lake houses and all, but the core, it starts the journey, the base starts with your data warehouses. Now, what are these business drivers and what are the goals and principles that are associated? The primary driver for your data warehousing is that it can start supporting a lot of your operational activities, compliance requirements, and the business intelligence activities that you have. Now, this is primarily, as you have seen, that in from a regulatory perspective, from regulations perspective, the regulator, time and again is now trying to see the data that is coming into the reports and audit requirements are getting very much stringent. They want to understand how the data is coming, from where the data is coming in, and they also want to get a historical view of the data because a lot of times you see the organization is not performing well, and then suddenly the organization's balance sheets and all started showing, good numbers. And then you start wondering. So a lot of times it's historical and transactional detail level understanding is also important, which data warehouses are able to provide, right? So data warehouses are known to provide historical and timeline as, timelines and as well as time uh, traveling as one of the key aspect, So time traveling is a very interesting concept these days. It's not that, it's the time machine that you have, but time travel is where you can travel back in time, and then once you have able to travel back in time, as in like for the previous incidents that has happened, the transactions that happen, you are also able to use that for your predictive analysis. Right. Now, from the goals and principles, that's the reason you can see first and foremost thing that you should be able to support your business intelligence activity. One of the key driver of your business data warehouses programs and business intelligence teams. So you have the BIO teams. Sometimes you call them as the MIS teams. Also, they basically do a lot of the business analysis and decision making use cases. At the same time, taking that, they are also able to get in more insights from the data. Now, some of the key guiding principles, as you can see, is to take it from the business perspective, how I can use it for my driving the business priorities. Like say, for example, one very useful use case is the data monetization use cases. Now, data monetization is where I am trying to identify opportunities using my data so that I can start monetizing out of my data sets. Then I will start with the end in mind. So when you say end in mind, what is the end in mind? What is your target use cases? You don't normally don't start that, I want to start bringing in that all the data and then I will start looking into, or rather better approach is what are the use cases that you want to achieve immediately, because data warehouses, if you take a long, big organization, let's say a banking organization, you will have loans, you will have liabilities, you have mutual funds, you will have investments, you have treasuries, you have insurance data, you have risk related data. So much amount of data is there, but all of the customer experience and all. But do you want to have every of those data sets right immediately? Maybe not. So what are your key priorities that you want to start with? So that's the reason when you start the end in the mind, then you know that what are the key priorities that you want to start with, and then you can start building. Think and design globally, act and build locally. So when you say think and design globally, keep my end vision in such a way that it is holistically, to create an enterprise related data warehouse, rather than going with just focus ones. But then your act and build locally is more where you can have those specific focus. Now, as I was mentioning, each of these areas, maybe you cannot build everything at the same place, because a lot of those data might not be even there existing in my, but I can see that yes, in the next 2 years, I can see those additional data would be coming in, so new kind of products and all which we organization wants to launch. So I can see that then it can start those data sets. Like for example, if you have trade as one area, maybe your organization is not giving bank guarantees. Okay. But now you can see that there is a pipeline, in the next 1 year, I can see bank guarantees will get started. So yes, at that time I want to include that, right? So even though I will keep placeholder for bank guarantees, I will not build immediately the bank guarantees. So, the entities and the subject areas. So I will try to do it in a more incremental fashion. Then summarizing and optimizing the last, but not the first. So when I say summary optimize the last, it's primarily how you can start building on your atomic data. So in your data warehouses also there are different stages. So like for example, you have your core data model, that you have the final data model. Again, there could be different types of schema, that will be schema based modeling that you have. But what you do is you try to summarize not in the data model layer, but you have something on top of it, which is also called as the data marts, which is nothing but the aggregated layer. So here what you do is, let's say you have your sources, source one, source two, source three. From there, what you do is you try to bring in the data and then keep it into a staging area. So again, here the data is in a raw format, in its atomic format. So from here, you will again keep the data in its, by applying the relationships between the data. So again, the data is atomic over here. From after that, you will, in the final layer, you will try to do the summarization. So summarization will happen not in the first, but at the last, at how you'll be trying to aggregate and summarize. Then it also promotes the transparency and self-service, as I was mentioning. Once you have the data warehouse, the other aspect is to capture the metadata. The metadata, once you start capturing the business metadata, technical metadata, then you can start getting more context, more understanding of the underlying data, and then it can start providing better visibility to all the stakeholders. Then also you start building the metadata along with it. It's not like a lot of organizations, they fail, in adoption of data warehouses. Data warehouses programs fails because you might have created a data warehouse, but there is no documentation, there is no proper guidance. So how organizations can start using? There are developers who will develop it and go, but there is no proper documentation. There is no, proper understanding of the warehouse, and then I will not be able to use it. So once we say that, we need to capture the metadata throughout my entire life cycle, development life cycle, operational life cycle. Metadata plays a very important role. And for understanding metadata, you can refer to the separate session on metadata where I have discussed metadata in very more detail. And so in collaboration is primarily data warehousing is not a one-man initiative or one team's initiative. Someone will think that is from IT. A lot of times it has to have a collaboration. Like for example, when you're creating your data models, you know, you will have to sit with your business and IT, map all the data fields. You do something called as a source to target mapping, which requires to have a involvement from the respective IT custodians. Similarly, the business has to ensure that whatever the data sets are there in your data warehouse is all complete, it makes applicable. So only once you starts getting, confirmation of all of this, there is so much times you will have to get access to, the databases, you will have to get read accesses. So you will have to, work with the teams. Then to drive the adoption of data warehouse, you will have to work with the existing all the departments, users who can start pulling out the reports, their operational activities. You will have to upskill them, try to train them. So it's an organizational activity. It touches each and everyone within the organization. So that's the reason the collaboration has to be there between all the different teams, not only with the data teams only, but with business, with operation teams, everyone. Okay. And one size does not fit all. So a lot of times, you'll feel that, let's say I want to take Snowflake, I feel, that will serve my purpose. Or let's say the thought process it starts, let's say Amazon Redshift I want to start with, or let's say I want to use a Google BigQuery, or let's say I want to use the Hive, as a data warehousing solution. So different organizations has different priorities, right? So identifying the right tools is something that is definitely a very important step, but one size does not fit all, right? So when you, let's say, for example, you might have created data warehousing in your past experience with some organization which might be having very less data. So if you start extending that same architecture to the other client where, you might have so much and large amount of voluminous kind of data, then it might not, suit. So that is the reason, you'll see that everything you will have to understand. And as part of the activities we have done this, right? What's the business requirements and all of it is part of. Now, one of the key aspects is we'll try to go through these some of the key concepts with respect to associated with data warehousing business intelligence. To start with, business intelligence is more where I am first trying to do a lot of data analysis, and I want to start improving my organizational success. So that's similarly business intelligence is also referring to a set of different technologies that I can start use for you doing this data analysis. So technology is just like a more of an enabler that I would be using. Now, data warehousing, on the other hand, it's a combination of two main components, primary components. So you have an integrated decision support system, DSS, and whatever the associated, software programs or technologies that might be used to collect the data, to cleanse the data, to transform the data, to store the data. So all of it is something that will be part of my entire journey. So from all the different sources and all this integrated decision support database that I'm trying to create. And this will also support a lot of my hierarchical, analytical kind of use cases, right? So that would be coming in. So I want to take these kind of use cases. So the data warehousing might be having this. And then on top of the data warehouses, we create something called as your data marts, right? So these data marts are primarily specialized output, specialized copy from the data warehouse, analytical output from the data warehouse. So some of the examples of data marts is like, for example, you see customer 360. So customer 360 is now where I want to get a 360-degree view of my customers' products and services, whatever the offerings that they have, and again, what are the things that you want to include? It depends on that, but it's more like a single view of my customers' product services and their engagement, so that I can help in understanding what are the possible, ways I can try to bring in and improve my customer experience aspect. Then you also have something called as a enterprise data. It's an integrated DSS kind of a thing. And you in data warehouse side, you have something called as a enterprise-wise data warehouse versus subject area specific data warehouse. Right. So like for example, subject area specific could be like you can have a credit card data warehouse, only for serving the credit card systems, right? Or you have a finance specific data warehouse. And then a combination of all of this, what you have, which they might have created individually, I can create something called as an enterprise data warehouse, which has multiple subject areas. So all the different subject areas within my organization could be available, right? So very interesting way of understanding this is like, for example, these are nothing but your specialized stores. Like, for example, you have an electronic specialized store, you know, electronics specialized stores that you have, right? Which will be only show storing electronics and electrical appliances, or like, for example, some retail stores, like, for example, Zara and all, right? And then you have enterprise data warehouses, which is like your Amazon, which might also be selling electronics, retail, everything, each and everything you might get in an enterprise-wide data warehouses. So the data warehouses, the models that you will have would be something different. Now, the approaches, there are different approaches to data warehouses. So most of the data warehouses, in fact, there are two influential leaders who have, driven the data warehousing concepts. So you have the Bill Inmon and Ralph Kimball. These are primarily the two main pioneers of data warehousing. In fact, Inmon, if you say how he defined data warehousing is, it's a more, he defined it from a subject-oriented approach, so he said it's a more of a subject-oriented integrated time variant and non-volatile collection of the summary and the detailed historical data it will have. And how Kimball tried to define is, Mr. Kimball said that data warehouse is nothing but it's a kind of a copy of your transactional data, specifically structured for your query analysis. Now, both, while Kimball and Nimble will have these different approaches, so one is, um, way that how you want to structure. So Kimball basically also popularized dimensional modeling, so dimensional modeling is where now you have these different types of dimensions, facts, entities, hierarchies, and all try to identify. So similarity does exist between Invol and Kimball, right? So for example, they both say that that these both of them will be storing the data from all the different types of systems. Then whatever the act of storage will include organizing the data in different ways that will try to increase the value. At the same time, data warehouses makes the data accessible and useful for the analysis aspects. Organizations will also try to build these warehouses because they might be required to make reliable integrated data available at a point in time that will be useful for their entire usage. And data warehousing might be serving a lot of the other use cases that you might be having. So these are some of the pointers that Mr. both of them basically mentioned. It's a kind of a similarities that might be existing between these different thought leaders. Okay, so you will be able to see these aspects over there. Now, additionally, what they mentioned is we also have the concept of the corporate information factory, which was popularized by Inmo, which you also have the CIF. Now, Inmo, a CIF, which is primarily is one of the primary patterns which is there within the data warehouse. Now, how he said this, as he mentioned that it's a subject-oriented integrated time variant non-volatile collection of summary having the historical data also. So here you can see the key components which are there. So one is subject-oriented, right? So subject-oriented is where I was mentioning, right? So there are different types of business areas that you will be finding, right? So rather than going and functioning it from an application perspective, which majority organizations to try thinking, like one application, it's a more of an application specific architecture. What Inmon mentioned is it's more rather than more of an application, it's a subject area. Like for example, the customer data could be they're existing into multiple applications from where it will be coming. So rather than thinking from an application, I don't want to replicate the app data into a single place. I'm not creating a more, you can say, just like a data store of copying the application's data into a single place. I am also want to apply the relationships between the data, right? So I will identify these business entities and apply these relationships to, so that what happens is once I want to fetch the data, once I want to take out the respective data, for me, it would be much easy. Otherwise, I will just replicating the same problem that I am having, the silos. Then integrated. The second component is integrated, where what I'm trying to do is the entire data which is unified and it is cohesive. The same structures, key structures, the encoding and the decoding of the structures, the data definitions, the naming conventions should be all applied consistently. Now, one of the reason is because let's say you want customers data which is there in applications, it might have some different types of structures. It might have some different nomenclatures, data types, and all in which it might be staying. So I don't have those inconsistencies which are there while I have the data from the different systems. I want to remove that. That's the reason data warehousing is not just a copy of your operational data. Instead, the operate data warehouses is more like a, you can say, a system of record. So this system of record concept I have explained you in your the topic of MDM, master data management. So you can go through that as well. So system of record is something that I will try using that. Then time variant, right? So data warehouses that I have, always store the data as it exists at a point in time, you know. So I also mentioned the concept of time traveling. So we normally try to keep kind of snapshots at a point in moment in time so that tomorrow, if I want to go at that specific point in time, let's say a specific date or a specific, month and all, I should also be able to identify and go there. So time traversing is also one of the key component of a time of a data warehouse. Since then again it is non-volatile. Now, what is non-volatility? So these records that you normally have, they are updated as they are in your operational systems, right? So as the new data is being appended to your existing data, so you would be able to see that these records are being updated, right? So that is again a very important aspect where what I try to do is these different states is something that I would be maintain, right? And then you also try to do something called as an aggregation, of your data. So the aggregations is primarily where you try to keep the data at its atomic level, at its lowest granularity, all of it. But at the same time, you also want to try and aggregate the data, right? Now, an example of an aggregation data is, let's say, for example, you want to capture all the transactions that is done against your account, bank account. So you will take all the transactions, just like you might be seeing this in your passbook entry, your account statement where you have all the individual statements. But then I also want to know by end of the day what is my debit and credit, right? So I want to get it in my a daily view or a monthly view. So that is an example where I will keep my transactional data, which is at the granular level. At the same time, I will also try to aggregate this data, you know. And then, or this is also called as the summarization, which I will do. And then I also keep my historical data. The reason I want to keep my historical data is now I want to there's regulations that mandates definitely that's the thing, but then I want to see my trend analysis. I want to do understanding of my periodically how it is changing, how it is moving. Now, this is what Inmon mentions. Now, dimensional data model is one of the key aspect as for which is being again mentioned by you know, Kimball. So Kimball primarily mentions that the data warehousing has a kind of a pattern, so as he mentioned that it's a more of a copy of your transactional data, which has been structured, right? So you need to put, a kind of a structure. So the data which is present in the data warehouses will be there as part of a dimensional data model. Now, data dimensional model will be designed so that you can start enabling your data consumers, how they can start understanding, they can start using the data at the same time. They can start looking at your query performance. Now, there are different types of models that you have as part of the data warehousing dimensional model. So one such popular model is also called as a star schema based model. Now, star schema, as the name suggests, is in the form of a star. So in the star schema based model, there are different components that you will have or different entities that you have. So such entities includes your dimensions, your facts. Okay. Now, these facts are primarily also called as your transactional kind of data, holds your transactional data like your sales orders, your, the transactions that you do, all these kind of things. Whereas dimensions will be storing your dimensional type of data. So those kind of data which will not be changing very frequently. So an example for that is, let's say you have a customer dimension. So in your customer dimension, you have fields like customer ID, customer name, first name, middle name, last name, right? These kind of fields are fields which are not changing frequently. When I say frequently, sometimes it might change. Like for example, the last name of the customer can change, maybe once in a lifetime after marriages. A lot of times you have change name changes, or as per astrology, you want to change your first name. So you'll change, but you don't keep on changing every day, right? Your names. But associated. Similarly, you can see like there is an account dimension that you have. So we shall have the account ID, fields which will not change. The account number, the account, name associated with the account name, right? These fields. And then you have a branch ID, right? So within this, you can see some fields might be changing. Like for example, the branch. Let's say you want to transfer your account to a different branch. So then the branch will change, but again, you will not change your branch every hour, every minute. It changes maybe very less frequently, right? So these are the attributes, or these are the fields that normally you'll find in dimensions, which will store descriptive attributes, And then you have the facts which will store your transactional related data, right? So all the account transaction fact that you have. So which will be having details like, for example, the account ID. You have the account ID which will be acting like a corresponding foreign key over this table. You have the transaction ID, you have the transaction number, right? You have the transaction amount, you have the transaction status, like kind of thing. So this will keep on changing for each new transaction that you're doing, right? So those will be captured. So when you see the diagram that will be shown for your star schema based model, so normally what you have is you have something, a fact in the center, and these are being connected by the different dimensions that you have. So that will basically help you to create a kind of a star kind of a model, which is also called as the star schema based model, right? So your fact which will be there at your center will be surrounded with your different dimensions, right? So there could be multiple dimensions that will be there. So this start representing the in the form of a star. Hence, it's also called as the star schema based model. Now you can see that you have these subject areas that you have date, product, store, vendor, and then these are the different business processes. Then you start creating them in the form of a data warehousing bus matrix. So these data warehouse bus matrix will try to show the intersection between my different business processes that is generating my data sets and the different subject areas, right? So these different subject areas might be representing your different dimensions. The business processes, you can start seeing that they will be generating a lot of your facts related data, right? So that is how you can see a sample bus matrix. As you start doing it for your organization, you can start seeing more complex, right? Here you can see that a conform dimension as another thing, right? So when I say conform dimension, it's primarily conforming to the different dimensional related concepts that you have, right? Now here you can see, so going ahead, you can see the star schema based model in the data warehouses. So from your operational data sources, the data as it is coming in your data staging areas, you will try to get the data and keep the data as it is, where you will not do any kind of a processing and changes. But in my data presentation area, you will try to create your data warehouses, data marts that you have. And then in the final layer, you will try to see that how you want to start putting out the data. So these figure that you have, the data warehouses or components that you will be able to see will have these different aspects, right? So as you can see, this primarily keeps on evolving the entire life cycle. As you can see that it gives you a single view, right, from your source systems from where the different data would be coming in. In between, you have the data integration layer where you will be doing your ETL, ELT kind of data movement exercises, integration exercises, and then you start creating. And so that will help you. So this is primarily a single view. Here you can see how you can start representing the entire operational data coming in from the operational system. In your staging area, you try to keep cleanse, integrate, and enrich, standardize on top of the staging area and bring it into your warehouse, which is more of a subject-oriented, non-volatile, time variant, atomic historical data you'll keep. And then from there, you try to pull out the data in your dependent data stores, right? The ODS, data marts, and the different cubes. And then you also parallelly start doing the vast data management, the MDM activities. And then it could be once you have the data in your warehouses and your data marts, then the business intelligence users can start pulling out the data for your operational reporting analytics, geospatial, demographic analytics, performance management visualizations, data and text mining, unstructured analysis, predictive analysis, machine learning kind of use cases, right? And this is for your structured data, and on the other side, you have the big data is coming in, right? So you'll not keep it within the warehouse. You try to integrate and try to bring it into your data lakes, right? So as you can see that within the use cases would be similar, but you can see that I will want to bring this unstructured data into my data lake, and then I can process it and put it into my data warehouse also and put it to a structure as well. I can put it into a data warehouse accordingly. Now, there are different types of data that you will be able to find out, right? So, for example, the first kind of data that you will find is more of a historical kind of data, right? So, historical kind of data is one of the key benefit of finding or one kind of data very popularly find in your data warehouses, which is not in your operational systems. So because capturing the history or capturing the snapshots that we can have, reproducing the point in time snapshots that we require is very much important, which is not the capability of your transactional systems, right? So that's the reason in your data warehousing, as you are able to store the data in the data warehousing layer, I will also try to create these snapshots available. So you can see that data warehouses, that's reason is very big. If you have your respective transactional systems also, which is big, then data warehouses is just a consolidated layer. So you can just imagine how big it is. And you cannot bring every data of your transactional systems in your data warehouses, though the idea will be there to bring it. But normally the data which is redundant, not usable, which is not business critical, we will try to keep it and use it within my operational data systems. So the data warehousing, you will be see that there is a combination of these data sets that you have, right? And if you know that nowadays there is a very popular approach, which is your data vaults. That is, you can see now data vaults is getting popularity and is used along with your data warehouses, where you have the entire hub satellites and links concepts coming in, and accordingly you will be able to start using these data sets and start taking usage of this. And then you also have the batch change data capture CDCs. Normally, data warehouses initially in the traditionally where the data sets that we were getting was not real time. So it was being done in the form of a batch at the end of the day when the business critical applications were not being used so much. So I will start processing, taking the identifying those data sets which has changed, and I will try to move them into at the end of the day to my end of the day into my data analysis. Now, as the real-time use cases start coming in, right? Now, I also don't want to bring in all the data sets, right? So I also want to identify what is with a kind of a change detection, so that I will only identify those data sets which are changing, right? So now what I can do is I can look at my logs and see that which are the data sets which are changing, or which are the fields that are changing, and only identify those candidates to be moved to my data warehouses, right? So rather than refreshing, reloading my entire huge volume of data sets, millions and trillions of records, which might be too much deduplication of work, I will not do that. So what I will do is I will do timestamp or log table loads as one of the key way of loading and identifying this data. And one of the other benefits that some of the benefits that you can do is, see, normally what used to happen is if you start doing full load every day, one is it would be slow, it would be performance inefficient, and sometimes if it fails, then you again have to restart. So here, what you're doing is you're trying to identify change data capture techniques, where I can try to identify if there is any kind of a change that is happening in my data, and only identify those data and then break it into my target. Now for this, there are different types of change data capture technique aspects. So once you have the time-stamped delta loading, where I will try to identify what are there in my in my source systems, and I stamp it with my system date, right? So this is a little less complex, but it is fact loading is fast and all. There's this kind of comparison, and you can see the dimensional loading would also be fast. That there could be some kind of an overlap that would be happening, and there is no deletes that is happening. Whereas we can also take the log table delta load, where what I will do is I will take the source system changes, which are, I will keep it log into a separate log table, right? Now this will be a medium complexity because I will have to create a separate log table for it. Fact load would be a bit nominally less faster as compared to a timestamp, right? Because I will have to start going and referring with my log table and then start doing a connection between them. Then we have the database connection transaction log. So database, at an individual database level, I will start capturing the changes. Again, it will be a bit complex because at each of the database level, I will have to start making the changes, right? Which will be difficult. In message delta perspective, the source system changes are published as a near real time, right? So this is a very good one because you're trying to get a near real time kind of thing, but loading might be a bit smaller, things, because these four systems are being individually have to identify. And then you have the full loading, which is the most simplest one, but is the slowest one out of it, because you're not having any kind of a change indicator, and you're not able to compare what kind of changes is happening. So like this, there are these different change that is happening. Now, near real time and real time is more where you're trying to move it to your streaming kind of use cases or near real time kind of use cases, right? Because now what you're trying to do is you want to remove my entire latency in my data sets, and I want to start providing more integration capabilities, integration of your real time, near real time data sets that you want to start identifying. So one of the common application that you will identify of your operational BI is that how you can start doing your making your data sets available to the end users in more near real time. And can you start identifying some kind of these insights, right? Now, these changes that you will have, has to be isolated from your other types of data, which is more historical. At the end of the day, you can identify, right? So you need to identify how you will be able to do. So for that, there are three main approaches you can take. And you can take a trickle feed approach, you can take a messaging approach, you can take a streaming approach. Now, if you take your trickle feeds kind of an approach, wherein it is more of your source accumulation. So rather than running on a nightly schedule, trickle feeds will try to execute your data or batch loads on a more frequently schedule, like every hour or every 5 minutes and all, when there is a specific threshold has been reached. Right. So this threshold, we can say that it could be 500 transactions or some kind of a let's say 1 GB of data is being loaded, right? So it doesn't matter how much time it will take, even in 3 minutes it gets loaded. So what I will do is I will keep on processing this. And so this is more where you have the, you won't have multiple files getting generated, and you define a, that 1 GB file is can once gets completed, then start loading it to a new file, create a new file and all. So it's a trickle feed that we're mentioning. So what we'll do is if we start looking into how's the trickle feed batch, if it is taking more longer to complete, if the feeds are not very frequently generated, right? Like in use cases to use cases, it will be different. Sometimes in holiday season, sometimes during sales, the frequency increases. So I can do a time-based kind of a trickle feed. I can do a size-based kind of trickle feeds also, and I can accordingly have to change it based on the use case that I have. Then you also have messaging, which is again the bus accumulation, where you have the real time, where all of you might be knowing that how we have the publisher subscriber kind of an architecture. I can start using the messaging message brokers. I can start using, right? You have the rapid messaging queues, or so they are the message brokers, or Azure service bus and all, right? So they are the message brokers that you have, where you can see how they would be processing the packets into the warehouses, right? So the source systems and the target systems might be very much independent from each other. So you can use data as a service as very frequently as one of the key, method for establishing this. And then you have the streaming architectures where, rather than waiting on the source-based schedule, as soon as the data is being generated, immediately I will have to take and process and use it. So good example of the streaming is like your autonomous self-driving cars, right? I can't wait for, when the car is moving on the highway, and I will have to, at every point in time, I will have to start to, if the sensors are collecting the data, I will have to process and accordingly give commands to my steering wheel, to my brakes and all to apply. I cannot say that, let's say if there is an animal that is crossing the highway, I will have to pass that command to apply the brakes. I cannot say that, no, I will send a brake command after 1 day. At that time, there will be accident and everything will happen. So streaming, as the point data is getting generated, it is I'm trying to collect it. At the same time, immediately I would be able to process. It requires a different kind of an architecture. So these are the different types of activities. As you can see, I will want to understand my requirements, develop my data warehousing data marts. I want to populate the data warehouses, implement a business intelligence portfolio, maintenance of my data products, right? So all these are some of these different types of key components within I will be doing. And while I'm developing data marts, I will try to do source to target mapping. I will do data marts creation, those kind of these different individual things I would be able to do. I want to also remediate and transform my data, right? So these are the key aspects that you would be able to see that I want to implement. For that, I will be using these different types of tools and technologies and techniques as a whole to establish this. Right. And then the very important aspect is the governance aspect, right? So how you will be able to establish the governance, the data warehousing and the BI governance aspect, right? So the governance is because, a lot of times you'll face a lot of challenges, when you will be able once you want to drive, right? So first and foremost thing is to take the business acceptance of the scope. So taking the sign off, then doing the conceptual data model creation, data quality, end-to-end metadata aspects, end-to-end lineage aspects is all something. So data modeling is not only limited to your conceptual, but then you do the logical data modeling, you do physical data modeling aspects, you do everything of it. And one of the key important aspect is to continuously evaluate and take feedback and do peer review. So if you keep on doing that, then there is no those misses you will not have, right? Then you define your service level agreements, that what is defined and what is required in your, warehouse as part of an immediate requirement as is. What is something that could be good to have in the next steps, right? The service level agreements, once you have the business and technical expectations document, then you also try to take some of these aspects, like for example, what is the response time, because accordingly those strategies you can do. What is the data retention period, you know, then what is the availability requirements, right? So this kind of aspects you look. Then on the reporting strategy perspective, how the reporting strategy will be existing within the business intelligence portfolio, what are different standards, processes, guidelines, best practices, procedures that you're going to use as part of it. And then lastly, the different types of metrics like the usage metrics, how many number of registered users are coming, how people are using, what is their adoption rate, all these kind of things. On the subject area, coverage percentage. This will help you to understand whether your data warehouse is complete or it still lacks a lot of the critical business functions, right? And then the responses and the performance metrics will be useful for identifying the what is the when you're putting a query, what how fast your is your the response coming out, right? So these are very useful, when you want to evaluate the performance of your data warehouse, the model that you have. So, and this also basically acts as an enabler for your performance tuning perspective, right? So how you want to drive your entire architecture, how the entire performance metrics will help you to evaluate how's the performance in the data in the warehouse is looking like. So these kind of things all will be the critical key aspects, the metrics that some of the few ones which I have mentioned, there could be so many other metrics that you can start evaluating. So yeah, I think this was something that we wanted to cover on data warehousing as a concept, as a topic, data warehousing and data intelligence. Now, again, this is at a very high level because each of these topics that we discuss, is a very course in itself. Well, so I run different programs on each of these topics, right? So separately, these are almost, 20, 40 hours sessions where we design data models and all. But I was trying to squeeze all of that information into an hour so that it is useful for you from the certification perspective. If you're trying to go for CDMP, this is at a very high level that is being asked. But digital ones is something that, as you go and create these data warehouses and all data models that you do, you'll get a better expertise on it. So I will look for bringing out and taking out some more individual sessions on each of these so that you start getting a better picture on each of these topics. And with that, having said that, we will wrap up with today's session. But I will come back again with a new topic, a new session. Primarily, the few ones which are remaining that we look for, and then there's a lot of ones that I have planned to take it in the days to come. So, looking forward to coming and presenting on these different topics and sharing the knowledge with you all. So thank you, everyone. I'm gonna wrap up today's session. I will meet you in another exciting episode of Data with some data topics. Thank you. Take care. Have a nice day. Bye.